inequality. Okay? Why is it called an inequality? Because it is not equal. So here's the idea. We have an inequality, something not equal to, but instead greater than, less than or equal to, greater than or equal to, like all the things, right? All the things. Now, what we're going to do is we are going to graph x is greater than 2. Have you done this before? Absolutely. Is this review from 6th grade? Absolutely. So is this hard?
No. Yes.
Maybe.
Yes.
For many of you, you will draw the arrow the wrong way. And then I will get angry and I'll go, ah! And then you'll go, and then I'll go, ah! And then you'll be like,
we'll just sit there
and
cry.
So, number one. The most important part of your number line.
What is it?
It's the number that I'm concerned with.
Wow.
Okay? So like what's the number? Like who's the guy? Who's the guy? You know?
2.
It's 2. So 2 goes in the middle. Then that you have your interesting part in the center. That's why Kara and Riley sit in the middle. They're the interesting ones. All the rest of you, you're on the peripheral of the class. But they're like front and center, right in the middle. Okay? Sorry. Okay. Yeah, like the stuff, like steak sauce, right? A1, like, anyways. Now, everything else goes around the number that you are interested in so that you can better see what's going on. Now, what numbers, give me a number from this list that is greater than 2. Yeah.
865.
That's not on this list. 3. Excellent. 3 is greater than 2. How about
4?
4, 5, 6. So these numbers, right? Because the x is on the bigger side of the little, like, chompy, right?
Alligator.
So it's the bigger number. So I want x is greater than 2. Do I want x is equal to 2? No. So I'm going to do an open circle and then go to the right. Because if I check any of these points, sorry for boring you, then I will see that 5 is greater than 2, 3 is greater than 2, 6 is greater than 2, and so on. Happy campers?
Yeah.
Now we are going to add one level of difficulty. We will do the same problem, except they are going to specify something called the domain. And the domain tells us what flavor of numbers we can use in our answer. What flavor? That's right. Much like Baskin Robbins, and there are 31 flavors of the iced
Baskin ramen.
and there are 31 flavors of iced cream. We also have the different flavors of numbers. Remember we talked about them a few days ago. The whole numbers, the integers, the counting numbers, the natural numbers, the rational numbers, the irrational numbers, and then the real numbers, right? So the domain would be real numbers. Why? Because I've included all the irrational numbers, all the rational numbers, like they're all there. What if I asked for the domain to be integers? Could I include this number right here, 2.5?
Yes.
Really? 2.5 is an integer?
Yeah.
Look at your notes. Is 2.5 an integer?
Yes.
Yeah.
No.
Excellent job, AJ. No. Why? Because integers are the whole numbers and then negative whole numbers. So, I'm sorry. I'm not waiting. I refuse to wait. That is what integers are. Remember the building blocks, right? You have to learn the stuff from before to do it today. If you chose not to learn or have suppressed that memory due to lack of sleep,
What's real numbers?
That's every number you could possibly think.
The opposite of fake numbers.
What about negative?
No, it is the
Fake numbers is a real thing.
Positive number.
it is the complement to imaginary numbers.
But fake numbers is a real thing. Joe.
No, imaginary numbers are real.
Fake numbers.
Fake news. Go get a drink. Go back to the drink. Okay, moving on. So we have the goodbye. We have the integers. Now we will draw our graph the same. 2 goes in the middle. 3, 4, 5, 6. Okay, there we go.
Oh, no, sorry.
Welcome back. So, now I want all the integers greater than 2. How is this going to look different? Is 2 greater than 2? No. It is equal to. Remember, inequalities. So, no need to have your book open. It may tempt you to work on your homework instead of paying attention. In fact, I believe I asked that books not come to school. So you can go ahead and close that. And we'll open them once the lesson is over. Okay. So, if I want x is greater than 2, then I'm going to include all of the numbers, since it's integers, greater than 2, but nothing in between. Not a 2.5, not a 3.2, not a 2 3/4, none of that, because those would be rational numbers.
Rational.
But I only have integers, so the answer looks like this.
I don't get it.
Rational.
Well, that's good. You're in school, which means you will learn to get it. If you knew everything, you would be up here, and I would be down there. This is an excellent place to learn.
That's smart.
So, the integers are only the number part, right? If I were to write out the set of integers, maybe like and so on, right? So those are all the possible options because these are the integers. Now, if I cross out all the ones that are not less than 2, I get these ones. And so I have filled in dots indicating at those points that x is greater than 2, and they are included. But I can't include the numbers in the middle because the set of integers, this is why we've been doing all that stuff with sets. The set of integers does not include any numbers in between. The real numbers do, and that's why we drew this solid line here. But integers only include the numbers, the whole numbers, themselves. So I fill in the dots. Then I put an arrow to indicate it goes on forever. Okay? So that is that. They could also say positive integers, negative integers. Okay? So what is the set of positive integers? It's all of these. Do we include 0 in the positive integers? No. So it would just be 1 and so on. These are the negative integers. Okay? So, if you're doing your number line and they say this with negative integers, you would draw nothing. You would just draw the number line. Why? Because there are no negative integers that are greater than 2.
Wow.
Okay?
Pretty good.
I see your hand. I'm not done yet. Okay. They could also say whole numbers. You would include 0 there. You could also say counting numbers, and you would not include 0. Okay. So anytime it's any of those, you'll put filled in dots instead of doing the line. Yes.
If 0 is not
It is neither negative nor positive. It is 0. Okay, moving on. That's okay. There's plenty of things that are not either Or.
Like what?
Your table is not a car nor a train,
It can be.
But
It can be made into a car.
but it's a table.
If you put some wheels on the bottom and like make a little.
Do you want to argue?
No.
Okay. Sounds like you want to argue. And we're not here to argue. We're here to learn. Okay. There are plenty of things in life that are neither one thing or another. That's fine. You move on with life. Okay. For example, apple cider is neither a soda, even though it's a sweet drink, nor is it a type of sparkling water, even though
Ow.
like apple cider.
Apple
Like
cider.
boys, straight apple. No, that's vinegar.
Oh.
See,
It's-
so like
Sweet, but apples-
there are plenty of things that don't fit into categories that we've created in our minds. So don't let it be a stumbling block for you. Move on with life. Okay. Now, the last part of this lesson is the additive property. You're still talking, but the additive property of an inequality. So you will be asked to solve things or to graph the solution of this. And the advice I have for you is as follows. Anything that you can do with an equal sign, you can do with a greater than sign, you can do with a less than sign, you can do with a less than or equal to, or greater than or equal to. So, if this were an equals and you wanted to solve for x, what would you do?
Move over to 2.
How? Move over is not a mathematical operation. Yes?
Subtract.
Subtract. Correct. Subtract 2 from both sides, and x equals -2. But if this was greater than, then this is greater than. That's fine. So you're allowed to add or subtract from both sides without issue. Can we graph this? Sure. Here's -2. I want real numbers, and x is greater than that. So. Not a problem. Okay, so you can add or subtract from both sides without issue. And that is problem set 64.